want to talk to you about your Section 2D notes. You should have already written them in your notebook, however you are doing that. If you printed this page and then wrote them in, or if you wrote them out on another piece of paper. Section 2D is called Changes of States of Matter, and it is tied to states of matter, which we did in 2C. So, the change of state is defined by the conversion of a substance from one physical form to another. Okay, all we're doing is changing the form. All changes of state are physical changes. That means the identity of the substance did not change. So I know I've asked you this before, but if we have liquid water, what is the chemical formula? It is H2O. If we have solid water, which we call ice, what is its chemical formula? H2O. If we have gaseous water, which we call steam or vapor, water vapor, what is its chemical formula? H2O. The identity of the substance did not change. It only changed a physical form. So the key for that is the energy, which you have in the middle of the page there. Energy changes during a change of state, and it's related to the motion of the particles. Remember, we have solids that are just vibrating in place. We have liquids that are sliding past other molecules, and then we have gases that are just going 100 miles an hour, bouncing off each other and the walls of its container. So just like for you guys, if you add energy, the particles are going to move faster. If you remove energy, the particles are going to move slower. Now, and if I asked you what the temperature was today, you would tell me 42 or whatever it is, a number probably. Temperature by a science definition is actually the measure of the speed of the particles, and therefore how much energy it has. And heat is a transfer of energy, which we will talk about later, okay? So that, I think, takes care of your notes for this moment. Now, I want you to look at your changes of state graphic. There is at the top a chart that says part 1, and there's a chart at the bottom that says part 2. All right, so here's what we have. We have the change of state of melting for the first one, and the direction says state to state in the middle column. So when something melts, it goes from a solid to a liquid, and that's all that I would put in the middle. If you need to write out solid to liquid, write out solid to liquid. And then in the third column, I would like you to give me an example. So anything from everyday life, although I would like you to try to think of one that doesn't have to do with water. That makes it a little bit harder. Wax from a candle might be one. Popsicles might be one. Ice cream left out on the table might be one. Anything that goes from a solid state to a liquid state. Ice cream melted on the table in the bowl. It's still ice cream. It didn't change its identity. It changed its state of matter. Freezing then is the opposite. Freezing is when we go from a liquid to a solid, okay? So we start in the liquid state where the molecules are sliding past one another, and then we go to a state of where they're just vibrating in place. So the opposite of any of these would be true. We could take popsicles and freeze them. We could take liquid wax and make candles. I think lava is another good example. Once it cools and becomes solid, from science, that would be a good example. let me just caution you with this. Freezing does not mean cold temperature. Okay, freezing does not mean a cold temperature. So think about this for a minute. Last night I thought I would be Betty Crocker, and I thought I would make some cookies. And I needed to have some melted butter. So I melted some butter in my saucepan. It started as a solid. Think about this for a minute, guys. It started as a solid, so all the molecules are just vibrating in place. I put it in the saucepan and turn on the heat. The heat is transferred from my stove to the saucepan to the butter. Now remember, temperature, and the temperature is increasing because I turned the stove on. So remember that the temperature is nothing more than a measure of how fast the molecules are moving. So they're just sliding past, or they're just vibrating in place, but then they start to vibrate a little faster and a little faster, and then they start to slide a little bit, and then they start to slide a bunch. And they become a liquid, okay? I take it off of the stove, and I'm going to do whatever it is that I'm going to do with it, and the doorbell rings. And so I go take care of that, and then when I come back, my butter is in a solid state again. Now let me just point out and try to bring some things together for you here. Remember, a liquid will take the shape of its container. So when it's frozen back into a solid, it's not back into its stick, it's the shape now of the bottom of the saucepan. And freezing has nothing to do with how cold it is. It has to do with the temperature when the molecules start just vibrating in place. They lose energy and they just start vibrating in place and become a solid again. So it doesn't necessarily have to be at what we perceive as a cold temperature. Okay, it could be, but it doesn't have to be. Chocolate. You have any idea what the melting point of chocolate is? If you think about it, you put it in your hand and you hold it in your hand for a while, does it not melt? The melting point of chocolate is around your body temp. And you move it away from your body, put it on the table or whatever, and it will solidify again, which is another word for freezing. So I just want to point out that freezing doesn't necessarily have to mean that it is at what we say as a cold temperature. Okay? Let me get another color here. The next one is vaporization. Vaporization happens when we go from a liquid to a gas. Okay, this is not evaporation, this is vaporization. So the molecules are sliding past each other, they take in more heat energy, and at some point they start bouncing off the walls and each other, and they've turned from a liquid to a gas. So I have some ideas other than water. Gasoline on a hot day. Have you ever had to fill your car or maybe a mower or something, and when you take the lid off the gas can, you see that like fumey thing coming up? That's your gasoline turning from a liquid to a gas. It could be, some of you are familiar with breathing treatments. Most of those meds come as a liquid, and they are turned into a gas so that you can breathe them in. In some colognes, don't know for a fact, but I think that's how some vapes work. You have a liquid that's turned into a gas state so that you can breathe it in. So then, the condensation is the opposite of vaporization. Condensation, that's when we go from a gas to a liquid. This one's hard if you don't use water as an example. Dew on the grass in the mornings. When you go out in the spring or in the summer and your feet get wet because there's dew on the grass, that is condensation of water from the surrounding atmosphere. Your shower, which is again is another example with water, you take a hot shower and the molecules come out of the shower, the water molecules, as a liquid. Because you've added heat energy into the system, the molecules start moving faster and faster. Some of them turn into a gas. So they're bouncing off the walls of your shower and your bathroom. Some of them hit the colder mirror. Things in science always go from high to low. So if there's more heat energy in the molecule, it's going to go into the colder mirror. So the molecules are going to lose energy, and instead of sliding past each other, they're just going to start to vibrate. And they go back, or not vibrate, I'm sorry. Instead of bouncing off the walls and each other, they just start to slide past each other. They've lost energy to do that, and so they've gone back into a liquid state. And then our last one here. Sublimation is when a substance goes from a solid directly to a gas, and it does not go to the liquid state in between. These are a little bit harder, so I'm just going to give you some examples. Dry ice is one. In the old days when you went to concerts and they needed fog, they didn't have fog machines, they used dry ice. It is frozen carbon dioxide, and it will sublime directly from a solid to a gas and make the fog. If it's not written on yours, I would like you to add it. Deposition is the opposite of sublimation. Deposition is when you go from a gas directly to a solid without going to the liquid state in between. Frost is an example of here. Again, it's hard to do these last three without using water as an everyday example for us. Okay? So I want to make sure that you have this written down. You either have it put on another sheet of paper, or you've copied the graph, printed it off of your computer, and you have this information on there. Next time we will do part 2.